a kind of update on the long wave radio. The project that I'm working on for approximately 1 month, with many side paths. Try to make it in a super heterodyne way, but I finally got back to the TRF principle, and the schematic is here. I have already showed it in earlier videos, but anyway, perhaps it's still interesting to show. This proved to be a very good setup for a medium wave radio, say going between 800 kilocycles and 1.6 megacycles. And you see it here. And you can also see the elaboration. It was now made in a more neat way. And I have already also made a loudspeaker here on the radio, on and off. And I had to move the radio part somewhat to the right side, so that I now have a lot of space to mount all the coils that I need. And the final idea was to make of this circuit a radio that could receive on medium wave, short wave and long wave. And I did set many, say, pre-tests to get it working, and now I'm more or less in the final stage. I found that for long wave the coil, the radio coil, is extremely important to get good reception results. And I did an experiment yesterday evening to couple back a part of the signal to this coil, the long wave radio coil, especially the long wave radio coil of 3.9 millihenry, and I've talked about it in an earlier video. And I made a kind of coupling coil so that you could send back some energy, receive radio energy back to the tank circuit, the antenna circuit. And that's a so-called regenerative principle, often used in radios, especially in very old school radios of the 1920s. Regenerative means that a part of the radio signal is sent back to the tank circuit, here or here, via sometimes a small capacitor that is tunable, so that you can align the back coupling effect. And that means that the Q, the quality factor of the radio coil, so here the quality factor goes extremely up. So we couple back here in this example. Here is the power supply. In the lead of the power supply there is a coil. That coil goes to the tank circuit, and then it goes back to the positive lead in my case. And it's very important that the phase is correct, otherwise it doesn't work. And I want to show that in videos that in the future. So anyway, we sent a part of the amplified signal back to the first antenna coil, and then that antenna coil gets a very high quality factor. And it means that it receives its frequencies much better, or it doesn't receive its frequencies much better, but it's better and more specific amplified. The radio signal on frequency X or I. So the idea is now to develop this circuit further to a radio with which I can reach a TRF radio, by the way. So the TRF principle, we don't know what it is, go to the World Wide Web and study it. The TRF principle, and make it suitable for shortwave. I will use this coil here for shortwave. For medium wave I will use this coil here, and long wave, that is that kind of tiny coil that was also in earlier videos, 3.9 millihenry, and that's a quite big inductance compared to, for instance, this medium wave coil that has to work between 700 kc and 1.6 mc, and the long wave radio coil that is made to receive between 3 or 2 megahertz and approximately 12 megahertz. So these coils will be mounted here, and I will use these switches. You can use in such a case normal audio switches as long as the frequency doesn't go too high. And that means up to 12 megahertz you can use these normal audio switches to switch coils. Well, small demonstration.
Time to get away now. It's 6:10. Wednesday evening vibes continue.
Like our radio in England,
The winner and it.
United Kingdom,
Jay, your number ends with 748. I've just messaged you back, by the way, because
and received with this coil here. And there's more information in earlier videos anyway. Let's try to receive some other stations. This is, by the way, the high frequency amplification that's here. Here in the circuit. So we add a higher voltage to the first transistor. That's a normal NPN silicon transistor. And that means that the frequency differs, the amplification differs, of course. Pin connections, well, let's try to receive another station. And this is perhaps interesting to tell. In the Netherlands now, 10 November 2021, the medium wave band going from 700 kc up to 1.6 mc is dead. There are no radio stations. There are two particular radio stations, and they are Radio Columbia and Radio Paradise. Perhaps in other countries that is a completely different situation. But anyway, I'm living in the Netherlands, and that means that I have to cope with this situation. So I only have 2 Dutch radio stations on the medium wave and 1 radio station from London, like our radio. And I cannot give a too long demonstration. Otherwise, when I play music, when there's music played on a radio station, because I could get a copyright strike from YouTube. So that's why I have to stop now. The circuit works properly. Well, I tried to make the end amplifier in this way. Sorry, at first in this way. That was the tiny and audio end amplifier that I showed in an earlier video. It was not forceful enough, so I used the TBA2003, that's here. I've also made a video about that audio end amplifier, so perhaps I will give the link in the text box, the description of this video. Finally, what I also wanted to show is this. I bought in the past a few, say, surface mounted capacitors, bipolar capacitors of 100 nanofarad, so 0.1 microfarad, and I'm gonna solder it in now to an extra transistor stage that has to amplify the radio signal somewhat better before it enters the end amplifier. So I'm going to do that now. I've clamped it here in this kind of big crocodile clip. I hope it will work. And I only want to give a small advice, and that is when you solder here to such a surface mounted device, in this case, by the way, use a good quality wire, and then I mean a double stranded wire, because when you use, say, a fixed say a massive copper wire here and solder it, the wires can easily break off. That was more or less all to tell. Thanks for watching. Wish you luck. And of course I've clamped it here in a crocodile clip. Otherwise it is not very easy to solder to such a component.